For all of human history, we looked up at the night sky and saw a ghost, a pale, bone-dry disk of rock. We called the dark spots Maria, Latin for seas, because we wanted so badly for it to be like us. We wanted to find water. Between 1969 and 1972, 12 humans walked on that surface. They kicked up gray dust. They drilled into the crust. They brought back 842 pounds of rock and soil. When the scientists at Johnson Space Center cracked open the lunar sample containers, they expected to find the secrets of the solar system. Instead, they found nothing. No vapor, no ice, not even a molecule of moisture. The moon was a sterile desert, a vacuum, a place where water was impossible. Case closed. For 30 years, that was the truth. But science has a bad habit of mistaking absence for evidence. To understand why we were wrong, we have to go back even further. Before Apollo. Back to the space age before the space age. In 1961, a theoretical physicist named Kenneth Watson sat down at a desk, likely wearing a short-sleeve shirt and a skinny tie, and did the math. He published a paper that everyone read, but few believed. Watson looked at the moon's poles. Unlike Earth, the moon stands almost straight up. It has almost no axial tilt. Because of this, the sun never rises high enough to peek into the deep craters at the South Pole. They are permanently shadowed regions. For billions of years, some of these craters have never seen a single ray of sunlight. In 1961, a theoretical physicist named Kenneth Watson sat down at a desk and did the math. He published a paper that everyone read, but few believed. Watson looked at the moon's poles. Unlike Earth, the moon stands almost straight up. It has almost no axial tilt. Because of this, the sun never rises high enough to peek into the deep craters at the South Pole. They are permanently shadowed regions. For billions of years, some of these craters have never seen a single ray of sunlight. Down on Earth, the coldest desert gets to minus 60 degrees Celsius. Inside these lunar craters, it drops to minus 250 degrees Celsius. That's colder than the surface of Pluto. Watson argued that any comet that smashed into the moon, any water vapor that drifted across the surface, would eventually hop, skip, and jump. Scientists call this ballistic migration, until it fell into these cold traps. And there it would sit, frozen, for eons. It was a beautiful theory. But again, Apollo arrived. The astronauts landed at the equator, where the sun beats down. They found no water. And so, the theory of the cold traps was shelved, forgotten. The end of the Cold War brought a new kind of space race, cheaper, robotic. And in 1994, a small Defense Department satellite named Clementine flew by the moon. Clementine wasn't looking for water. It was testing sensors for missile defense. But when it bounced radio waves off the South Pole, the signal came back fuzzy, distorted, the way ice distorts radar. The headlines screamed, "Ice on the moon!" But the scientists were skeptical. The signal was weak. It could be rough rocks. It could be surface roughness. It wasn't proof. It was a ghost. 4 years later, in 1998, Lunar Prospector went looking for the source. It couldn't see ice, but it could see hydrogen, the H in H2O. Prospector found huge amounts of hydrogen at the poles. Huge amounts. But hydrogen is a liar. It could be water, or it could be solar wind, protons from the sun embedded in the soil. Once again, the evidence was circumstantial. NASA decided to go big. In 1999, they crashed Lunar Prospector into a shadowed crater on purpose. They hoped the impact would kick up a plume of water vapor. They pointed the Hubble Space Telescope at the spot. They saw nothing. No plume, no vapor. The dream of lunar water seemed dead. Again, it was a pattern. Hypothesis, hope, disappointment, denial. But while the orbiters were looking down from space, a geologist named Alberto Saal was looking at old rocks, specifically Apollo sample 74220. The astronauts called it orange soil.
These weren't rocks from the surface. They were volcanic glass, beads of fire frozen in time, erupted from deep inside the moon 3 billion years ago. Using a new generation of mass spectrometers, instruments sensitive enough to count individual atoms, Saal and his team at Brown University did something the Apollo scientists couldn't. They found water, trapped inside the glass beads. Not surface contamination. This was magmatic water. It came from the moon's interior. The implications were staggering. If the inside of the moon was wet, then the old textbooks were wrong. The moon wasn't a dry rock. It was a wet sponge that had simply evaporated its outer skin. Suddenly, the idea of ice at the poles didn't sound so crazy anymore.
2009 was the year the moon broke. 3 spacecraft changed everything. NASA's Cassini, flying by on its way to Saturn, NASA's Deep Impact, heading for a comet, and a newcomer, India's Chandrayaan-1. On board Chandrayaan-1 was a NASA instrument called the Moon Mineralogy Mapper, M3. It looked at the moon in infrared light, specifically a wavelength of 3 micrometers. On Earth, when you look at 3 microns, you see the signature of water and hydroxyl, OH, the dirty molecule of water missing a hydrogen atom. In September of 2009, Science magazine published the results. Not just at the poles, everywhere. The surface of the moon is hydrated, from the equator to the poles. In the burning heat of midday,
Carly Peters, the lead scientist, tried to calm the hype. "This is not lakes or oceans," she said. "This is molecules of water and hydroxyl interacting with dust." But the genie was out of the bottle. The moon was not bone dry. But 2009 wasn't done with us yet. Later that year, NASA launched the Lunar Reconnaissance Orbiter. Riding shotgun was a smaller spacecraft with a morbid name, LCROSS, Lunar Crater Observation and Sensing Satellite. The plan was brutal. They took the empty rocket upper stage, a 2-ton piece of scrap metal, and aimed it at Cabeus Crater, near the South Pole. On October 9, 2009, the empty shell hit the moon at 5,600 miles per hour. It was a suicide dive, the energy of 1.5 tons of TNT. 4 minutes later, LCROSS itself flew through the debris plume, sniffing, tasting, analyzing, before it too crashed into the darkness. The team at Ames Research Center watched the data screens. They were looking for a specific ultraviolet flash, the signature of water vapor. They found it. And then they found more. The plume contained 155 kilograms of water vapor and ice grains. Listen to Anthony Colaprete, the LCROSS project scientist. He said, "We didn't just find a little bit. We found a significant amount. We hit the jackpot." For the first time in history, humanity had touched the water on the moon. But even after LCROSS, the rule held. Water only lives in the shadows. If the sun touches it, the water evaporates into nothing. That was the law. Until 2020, when the law was broken. NASA's SOFIA mission was a telescope mounted inside a modified 747 jumbo jet. It flew above 99% of Earth's atmospheric water vapor, looking at the cosmos in far infrared. In 2018,
They pointed Sophia at the moon, specifically at the Clavius crater, a massive, sunlit plain near the southern highlands. Previously, the 3-micron signature couldn't tell the difference between H2O, water, and OH, hydroxyl. But Sophia looked at a different frequency, 6 microns. That is the unique fingerprint of molecular water. In October 2020, the results hit the front page of Nature Astronomy. Casey Hannibal, a postdoctoral researcher, had found the signature of water molecules in the Clavius crater. To put it in perspective, the Sahara Desert has about 100 times more water than this spot on the moon. We aren't talking about an oasis. We are talking about a sprinkling. A few 12-ounce bottles of water spread out over a cubic meter of dirt. But it was there, in the sunlight, on the surface. How? The theory is that the tiny water molecules are trapped inside impact glass, melted sand, or sheltered in the nooks and crannies between mineral grains, protected from the vacuum of space.
So, here is the true story. For 50 years, we told ourselves the moon was a lifeless, dry graveyard. We told ourselves that story because we looked at the wrong places with the wrong tools. The truth is that the moon is a chemical factory. It is a dynamic world in slow motion. The water comes from 3 places. First, comets, ancient impacts that seeded the poles with ice. Second, the Earth. Some of our atmosphere may have been ripped off and landed on the moon billions of years ago. Third, the solar wind. The sun spews protons. When those protons hit the oxygen in the lunar dust, they make water. Right now, today, the sun is raining the ingredients for water onto the moon. We used to think the moon was dead, but it is breathing. It has a water cycle. As the surface heats up in the 14-day-long day, the water molecules hop. They migrate. They bounce along the surface until they find a cold trap, a shadow, and stick. We used to think the moon was dead, but it is breathing. It has a water cycle. As the surface heats up in the 14-day-long day, the water molecules hop. They migrate. They bounce along the surface until they find a cold trap, a shadow, and stick. Why does this matter? Why spend 50 years chasing ghosts? It matters because of in situ resource utilization, a fancy term for living off the land. Right now, it costs $25,000 to send a single bottle of water to the moon. It is the most expensive liquid in the solar system. But if we can land at the South Pole, at Shackleton Crater or Shoemaker Crater, we don't have to bring water. We just need to melt the ice, boil it, filter it. We can drink it. We can breathe the oxygen. We can split the hydrogen for rocket fuel to go to Mars. The story of water on the moon is not a story about the past. It is a map to the future.